All right. I think we're getting everybody on board. Hi, everybody. Welcome to the next big thing in AI, which is where for our session today, where CEO vision meets CISO approval. And I will be recording this meeting. Looks like Pernill's okay. I approve this.
This meeting
Yeah.
is
So
being
just
recorded.
everybody know. Don't say anything incriminating. Here we go. All right. Everybody, welcome. I'm thrilled to have you join today. I'm thrilled to be talking about what we're talking about today. My name is Chris Tabish. I'm a co-founder of Venture West Consulting, and today I'm partnering with Atsign, and I will get into the introductions in just a moment. But I just a little bit of context on what we'll be presenting today. I was talking with the Colin from Atsign, and he was showing me this technology, and uh, I was floored. I was astounded, and the first thing I said is, I really think we need to demonstrate this to people. So, as part of our ongoing Venture West webinars, I said we have to get this in front of people. This is so exciting. So thrilled to have you here. I think we're going to have a presentation portion, and after we admit several people, we're going to have a presentation portion, and then we're also going to do a demonstration. And this is the demonstration I'm thrilled to present. And then we'll have a just sort of a call to action, but a Q&A session as well for folks to get in the questions and any comments that they have as part of what's been shown today. So I'm going to jump right in. Feel free. I want to make this pretty casual and informal. So if you have questions or comments, just let me know. You can put them in the chat. I will be checking it once I hand over the presentation, or you can just feel free to call out any questions you might have. Okay, so a little bit of introductions, just a little bit about Venture West. Again, I'm co-founder of Venture West. Aaron Wilkins is my other co-founder. He's on the call as well. We were founded in 2018. Our bread and butter is really, program management, change leadership, and technology implementation. But we have really gone in deep on AI and intelligent automation. We have assessments and implementations under our belt, and we're very excited about the technology. And I think a big piece of that is showing people what the technology means, sort of demystifying it. So as part of that, we've been doing these ongoing webinar series. This is one in those series. And again, this is in partnership with Atsign. And with that, I want to give a quick introduction to our presenters today. So the first one is the CEO and co-founder, Barbara Tallent. So Barbara founded the company with Colin and another gentleman as well. They have been leading Atsign, which I'm not going to steal their thunder. It has I will say, a key differentiated technology from a security perspective, as well as the AI tool that you'll be seeing today, which is phenomenal. So, under Barbara's leadership, that has built the technology, and in addition to that, gotten to the tool that you'll be seeing today. And then, in addition to that, Colin Constable, Colin and I go way back to where we were with Juniper Networks, where I think we heard the term AI maybe once a month if we were lucky, to where now you hear it on a daily basis. So, Colin and I were leading the Juniper on Juniper, which is still in place today. So, he's been a friend and a business associate. And Barbara and Colin, welcome to the webcast.
Thank you. Thank you for having us.
Yeah, and with that, Barbara, I think I'll turn it over to you for the presentation before we get into the demo.
Okay, let's see if I can run this. I can, yay. Okay, so what we're seeing in the market is there's a bunch of different statistics on this, but we're seeing a lot of people creating some amazing AI projects, and they do these beautiful demos. But when it comes to actually deploying them, it's really hard to get them out the door. And there's a lot of reasons for that. Primarily, security vulnerabilities is a big one. And we find CISOs getting very frustrated with AI and just the fact that it's violating all the security protocols that they've spent their entire career trying to put in place. as well as scalability issues, but also just visibility. When you're coding with AI, people feel like it's kind of a black box and they're not really sure if the product coming out the other end is doing what it's supposed to be doing. So we are looking to solve all of those problems.
Right.
So what we're proposing is a secure architected AI. And this is actually, believe it or not, much faster than vibe coding even. And of course, it's much faster than human coding. And it is much more secure because it's built on the atPlatform. And what the atPlatform is a security technology. We've built this over the last 7 years. It's open source. And I can't seem to go to the next slide, Chris. Can you?
Oh, yep.
Thank you. It's a great underlying foundation for AI because it's completely invisible to bad actors. You don't open up ports, so there's zero exposure on the internet. It's zero trust, and every connection is end-to-end encrypted. And it integrates easily with existing infrastructure, so you don't have to open up ports and firewalls. It also has an external name service, which I'll get into in a minute as to why that's important. But this underlying foundation is open source proven. It's a lightweight security model that is much more secure than anything on the market today.
Hey, Barbara, I know zero trust was a relatively new term for me. Do you mind just kind of talking
Yeah.
what that means?
Yeah, so zero trust, and unfortunately, it's been co-opted to a lot of people use it as a marketing term, but it means basically no one should be trusted. No one on the network should be trusted until they're proven that they can be. And what we actually do on the atPlatform is go even beyond that and say you can't connect to where you're trying to get until you've authenticated. And so if you think about the internet today, you go to a web server, you're already connected. And so you connect and then you authenticate, you type in your password. Well, we're saying you can't even get there. You can't even see the web server until you authenticate. So it's a totally different model than what is out there today. Did that make sense?
Thank you. And all of you on the Zoom call have been trusted. So that's you
Yeah.
guys are an exception. All right.
Be kind, Chris. Just Barbara, can I just ask there? So I'm struggling to visualize this. So where is the zero trust interface sitting to allow you to authenticate yourself?
I'm going to let Colin jump in here. He explains this much better than I do.
So what you get when you're using the atPlatform is a new address. So we're all used to IP addresses, and they have, you know, that's how the internet works. Everything works on an IP address. But we've conflated IP address with connectivity. And so, you have no choice. If you're going to a web server, you have to connect and then you have to authenticate to the web server. That's the way TCP/IP works. What we have done is created an underlying protocol that gives you a new address called an atsign, hence the name of the company. So you have an atsign.
Okay.
My atsign's @Colin, and I have to sign cryptographic challenges before anybody's even going to connect me to anything. And the way you do that without having any ports open on, critical infrastructure, your enterprise, your databases, your websites, is we have infrastructure on the internet where you connect to there, first of all. You prove who you are, and then we'll get you connected, then we'll get you to the data. The catch is, though, is, what if somebody breaks into that? So the architecture of the platform is whenever you have ports open, there can't be anything of value. So on the infrastructure we have, essentially we call them ad servers. They're a little tiny Docker container for every ad sign. It contains public data, which is public, so we don't really care about that, but we do cryptographically sign it, so it's public data that's been cryptographically signed. And any other data is encrypted with keys that infrastructure never has. And so that's how you get to a situation where you authenticate and then you connect, or you authenticate and then you get data, rather than the way we've done it for 40 years, which is connect and then authenticate. And that means that you have zero exposure, right? That you know who you're talking to before you have to do anything. And that's a bit of a sea change from what we've been doing for 40 years. But it's been increasingly important over the years of the company that we do that, because there's pre-authorization attacks every single day, and it drives me crazy. So we're trying. We have eradicated that vulnerability, I guess.
So if I go onto my laptop, will I open up an app that gives me a way in to start authenticating
Yes.
myself?
Yeah. We'll show you that in the
Okay.
demo. Yeah, absolutely.
Okay.
You're
I'm going ahead.
Yeah.
Forget it.
No,
No, go back.
I'm glad we could get that mental model sorted out, because the rest
Yeah.
of it will make sense.
Yeah.
But
Yeah,
that, but
appreciate
that
your
is,
question.
Colin, right? It's when I like I go to Wells Fargo, and the first thing I connect to their site and then I log in. And
Yep.
you're saying, no, first you log in before you're even allowed to the website.
Yeah, exactly. And you issue your own cryptographic keys. So when you get an Atsign, the first thing you have to do is issue yourself some keys and get the public side of those keys accepted. And so then you have a secret, and that secret can be, stored in hardware, stored in a file, wherever you want to put it. By default, it's stored in a keychain, which is dependent on the underlying OS. So if you're using Android on iOS, it's going to be stored in hardware. If you're using Windows, it's going to be stored in hardware. If you're using Mac, it's going to be stored in hardware. Linux a little bit different. So very, very strong authentication, and using the platform to store the keys. So we're not issuing keys. You cut your own keys on the hardware that you're using, which I think also changes the game. Like, issuing keys is never a great thing, because you have to trust whoever issued the keys. You can trust yourself in most cases.
Maybe not on this slide, driving slides for Barbara, but
Yeah,
other than that,
exactly.
Thank you, Colin. I think I'm starting to grasp it.
There's a lot to take in.
It's a
So
lot.
Yeah,
we'll treat you gently.
Yeah.
Yeah,
appreciate
no,
it.
on this call, Keith, it's a really good question, because I think there's two things that are, I'll say, historically for me, mind-blowing. One is the technology that we're talking about, and then two is the demonstration, which we haven't even got to. So a lot to take in. I expect a lot of questions on the call. So thank you for starting off the process.
Yes. Thank
problem.
you. Thank you for jumping in there.
Okay, I think
Okay.
we're
Yeah. Yeah. So right now people are coding without a foundation, and that's just like building a house without a foundation. It makes no sense at all. And this platform gives you that underlying security foundation. I'm gonna go to the next slide, Chris. So the other thing that is missing with AI today, especially when you're coding agents or apps, you're coding from a prompt. And if you think about, if you were going to build a house, you wouldn't sit there and say, oh yeah, I want a window and a skylight and a door. That's not how you would do it. You'd lay out a blueprint of where you want everything and how things flow within the house. And that's the piece that we're announcing today, is that upfront AI architect piece. Next slide, please. So what we're saying is, instead of sitting at a prompt, you go to a map, and Colin will show you this. You build your blueprint, essentially, where you map out your data flows. And the wonderful thing about this is you can review it with all the stakeholders. So everybody can say, yes, that data has to come from there and it has to go to there. And because you're going to build this on the app platform, all of those connections between those data points will all be end-to-end encrypted automatically. So you review that with all the stakeholders. Then you export a JSON prompt. And this is a very large prompt, and Colin will show this, that goes into the LLM of your choice. You can, and out pops code that will be somewhat what you want. It probably needs some tweaking, so it still requires a little bit of development. But the nice thing is then you can audit that code against that map. So you have really clear visibility into what your app or AI agent is doing. And you can use a different LLM to audit it just to make sure. So this is a much more powerful way to develop apps and AI agents. Next slide.
And I think, Barbara, the two things just to call out that are fundamentally different, because I think, from a natural language model like in Claude, you can say, hey, develop something like this, and it will develop that code. But the two things that are fundamentally different about this, one is the mapping process where it literally, like I kind of interpret it as a Visio flow that you can speak to in natural language. And the second one is already what we've talked about, is that secure access to the data, where even if you do develop something, you're still connecting the old way and it's not going to be immediately secure. I think those are the two key, as I understand it. Is that
Yes.
accurate?
Yeah, absolutely.
Awesome. Okay, next slide.
Yeah, so the other thing that is this enables a next generation of AI experiences. And I had talked a little bit about the fact that we have an external name service. What that allows is you can have an AI agent that goes across organizations and have different policy management in the different organizations. So this is something you can't do today. And it was so funny. We were talking to a very large company who was saying, yeah, we've resulted to email between organizations, the most insecure protocol you can use. This is a way to do it where you have the end-to-end encryption and the different policies in each organization. So cross-organizational agents. It also provides a chain of trust. As Colin pointed out, everything has cryptographic signatures, so you can have audit trails for agents. It also has restricted access agents. So agent delegation is a big thing everybody talks about today. You do not want to give your credentials to an agent. This is a way to give partial access to an agent. So you can say the agent has access to this resource for this period of time. So really fine-grained controls on agents. And all of that is kind of built into the app platform.
And Barbara, just to this, just to kind of articulate the significance of this, as I understand it, you have a leader, a government leader that's associated with Atsign, who looked at this technology and like, wow, we need this in every department in the government because it is the fundamentally more secure than the other solutions that I've seen. That's my understanding, but if there's any, is that accurate?
That's accurate, yes.
Yeah. Yeah, very cool stuff. Okay.
Yeah, so we believe that secure architected AI is really the future because it allows everybody to go at AI speed and yet have all the security that you need in place. And so with that, I'm going to turn it over to Colin for the demo so you can actually see what this looks like.
Thank you, Barbara. All right, let's see if I can share. Hopefully you can see my screen.
I'll stop sharing, Colin.
Yes, I can see your screen.
All right, so welcome to AI Architect. This is live, so aiarchitect.atsign.com. You can play along as well. I'm just going to start a new blueprint, and so you can see how it works, and then we'll load in some examples. So when you say when it's on you, you end up with a blank sheet of paper, and you can drag and drop components. So in the Atsign world, you are either a person, entity, or a thing. So a person's pretty obvious. An entity can be an AI. It could be some sort of intelligent agent. It could be a group of people. It could be a business entity. Doesn't really matter. But they're the sort of three things you're going to be. They're the things that can be assigned atsigns off the bat. But you may well have a process that can be assigned. Maybe this is a process you want to get some work done. Maybe you have an existing API that you want to bridge into. We've seen often people with APIs that they just don't want to change or they're not allowed to change. Maybe it's on old infrastructure, or in the OT world, it's just an API that they cannot change. And there's probably a whole bunch of other things that we haven't thought about. So there's another box. So essentially, you write in what you need and you tell your story here, and then you connect these boxes. So yeah, what are these? What are these connection types? Well, asynchronous. It's sort of fire and forget. It sort of feels like a store and forward. So if you've got an application that you don't know where the other end is going to be up and running, then you can use asynchronous comms, and it's as easy as dragging and dropping. And you can also put tags on this. You can you can tell the LLM that this connection needs to do something, and you can speak to these boxes. So rather than go through all this, I have one that I prepared earlier. And this is probably the simplest blueprint we have, but it is of a real life customer, and it's a real life application. So it's sort of interesting. So KYZ is a radio station. We got involved with them because they had a security incident. They're a station that's normally playing 60s, 70s, 80s music, and one Sunday evening they started playing Norwegian death metal out of the radio station. They thought they had some sort of security event. The president of the radio station is a friend of mine, and he said, "You know something about security. Can you come help me because they think we've been hacked?" It turns out they were not hacked. They had made a misconfiguration. We figured that out, and normal service was resumed. But I did say I'd have a look at the rest of the security environment. And they had a whole bunch of ports open to the radio transmitter. So although they weren't hacked, it would have been pretty easy to send out any music across the radio station if you knew what you were looking for. So they became a no ports customer. Essentially, you have no ports open on the radio transmitter. There's nothing to attack. And for my help, no good deed goes unpunished. I got invited to the board, so I'm now on the board with KYZ on the back of it. The next thing was, well, you've got no ports open, but how can we monitor the radio transmitter? And so this is the blueprint for a monitoring app of the radio transmitter. So let's just dig into detail. It's really simple. There's a radio transmitter, and it has stats available via a protocol called SNMP, Simple Network Management Protocol. Now, my original techie detail was I should go read the book and find out exactly how to configure that. And then you realize, oh, this is an LLM, right? So all I need to do is tell it what sort of radio transmitter it is, and the LLM can figure that out. So it's a Nortel VS series radio transmitter, and it uses SNMP, and that's all I need to tell it. That's the radio transmitter. That's the thing. We're obviously going to need some sort of agent to collect those stats. So this is the clues in here. So gather the stats for the radio transmitter for SNMP, put them into JSON format, and then send a notification to a listening atsigns. Now, atsign to atsign communication, as Barbara said, is automatically end-to-end encrypted and authenticated, and that's all you need to do. You just need to send a notification. The whole prompt for the app, very simple. It's a mobile application. Uses that application receives the JSON notifications and displays them as gauges. The station's very old school. We like old school dials and gauges, so that's what the application's going to show us. And Bob's the person that uses the app. So yeah, that's the blueprint. I don't think you can get a much more simple blueprint. And it's pretty easy to explain to the board, exactly what's going on. And this is the magic. You export the prompt. And this is the prompt that essentially is a combination of the nodes and edges of the diagram you've just created. So this is that's the JSON bit. And inside the JSON is a whole bunch of clues for the LM to build the application and build any agents on top of the app platform. And all of those, interesting enough, are written in Markdown. So it's a combination of JSON for the nodes and edges and all the clues that can get the application up and running, and a enough information as to where to go to get the information to write the application. And you just copy that to a clipboard, and then you pick your favorite LLM. I will just show you a really simple one. We have got customers using very complex multi-agent configurations, but for simplicity, let's just use Visual Studio Code, and I'm going to build with an agent. And what I would suggest to anybody is actually get a plan first of all, and then we can put it in. Now we have some new models out, so I found having the plan done by Opus 4.6, and then actually get the code written by Sonnet version 4.6. That's the way it is, and that's it. That's my job done. I just hit enter after sending the prompt, and wait 20 minutes. Now, you guys probably don't want to wait 20 minutes, so you're probably interested in what comes out. What comes out is an agent that you can deploy at the radio station, which I have deployed already, and an application. And what does the application look like? Well, I can show you. Let me just put this out the way. Straight off the bat, it looks like this. This is a Flutter app. We have the atPlatform speaks many languages, Dart being the primary one, and the framework on top of Dart that can create applications on Windows, Mac, Linux, iOS, and Android is a framework called Flutter. This is a Flutter application, and you can see this is real live data from a real live radio station. We thought this was amazing, frankly, because we didn't give it very many clues. If you think about it, we just literally just laid that out in the map. But there was some feedback, and the feedback was, I'd like to be able to have some settings on this, and this is the final thing that's on people's phones right now at the station. And to the point earlier, like how does this application get all the data? I'm logged in as Visual 61. So if I just log out, this is what you'll get. You can add an atsign from an encryptographic file. You can activate a new atsign, or you can manage your atsign. So these are essentially where those cryptographic keys are. And we can log in with the existing atsign that I've already onboarded. You can see that's Visual 61. And PCAM is public key authentication method. So in other words, you get a challenge, you sign with your private key that's held in the keychain, and then the infrastructure knows who you are, and you'll get a feed of those JSON messages. Over the weekend, this is how fast this stuff is running. Over the weekend, Gemini dropped a new model. So let me just close you this and show you what I did here. So it's exactly the same blueprint, but I added a little bit in here saying this SMP collector has already been written and is in place, and this is where the code is. So we can go find out. So you don't need to build this thing. And then I handed it to Gemini, because Gemini will then just build the application. It will know that we've already got this. We know what the format is. So build an application that will run with this existing agent. And this is what comes out. So this is a Gemini version. And now there's an argument as to which one's better. Gemini did a really good job. If you look at the settings on here, it's not too bad, but it looks pretty ugly, I think. If you look at the settings on here, I think this is just nicer. Isn't that nicer? So these models are moving faster than you can keep up. But what if you could have a blueprint you could just rerun? And that's exactly what I did at the weekend. I just reran exactly the same model and said, I don't want you to create me an agent. I just want a bit of code that does what I want, but make it better. And so that's exactly what we did. That is probably the most simple blueprint you're going to see. But what I can show you is a more complex one. I won't zoom into details because there's a really good story behind this. You need, what I found is I'm probably not, well, in fact, not even probably, I'm definitely not the person you want building one of these blueprints. You want somebody like Chris and Aaron to help you do this, um, because my technology depth actually becomes a limiting factor. What you really want to be able to do is focus on the business problem. And just like I found with it was my natural tendency to give more information to the LM to find out how to configure the radio transmitter. The LLM can do that. So pose business problems into the blueprint. And I only have my experience. The LLMs have the experience of all the things they've learned of. And so posing really difficult problems in the blueprint actually gets you really interesting results as a developer. You're like, oh, that's a really interesting pattern. I probably wouldn't have thought of that. And that's because it's a combination of all the experience that's available for teaching the LLMs. You still have code that you have to play with. It's going to issue code. It's not going to be right first time, but you've saved, I mean, in my case, weeks, in some of our customers' instances, months. So there's a story behind this blueprint, and I'll pass back to Barbara, and she can tell you the what happened. So back to you, Barbara.
Yeah, so this was an application that somebody had been working on for over a year. It was in beta, it was running on iOS, and he thought he needed more security around the application, so he was interested in the atPlatform for that. So he worked with Tinashe, who works with us, to build a map, and that was the map that you just saw. And he loved the map because it actually gave him insights into the application that he had not had previously, and gave him a way to talk about it as well. But the interesting thing was Tinashe then put that in an LLM and created his app running on iOS, Android, Mac, and Windows, and having many more features that he had put in his wish list that had not been created yet. So within a day, he had something that he'd been working on for well over a year. And it was a functional app. So the power is amazing. And then it was built on the atPlatform, so it had all the security on the back end.
Yeah, and Colin, just going back to the original example, it's pretty interesting that, I noticed that you just said, "Hey, I just want to have gauges," but you didn't specify I want to have all the different gauges that you had. You're kind of relying on the LLMs, that its expertise and its ability to break down that data. And what would you typically look at for
Yeah,
measurement?
what I actually did, so I built it using a whole bunch of different tools, and with Copilot, you actually don't get to see sort of much of the thinking. It's not sort of kept in the log as easy as some of the other tools. If you run it with Claude Code, it actually costs you more money because you're burning up tokens much faster. I found Visual Studio Code that the way that's charged is actually very, very reasonable because you're charged per prompt. And guess what? We handed a very large prompt. So that one prompt basically cost you 4 cents. But it can burn through a lot of tokens. But if you do it on Claude Code, you can actually see the log of what it did. And what it did for the radio transmitter was, oh, you got a radio transmitter, it's using SMP. I'll use an MCP tool to go out to the website, pull out the documentation and find out what the OIDs that nobody, maybe me and Barbara know what they are. they're the IDs that SNMP uses. And I would have looked that up, right? With my technical head, I would have looked that up. There's no need, right? There's so many things that the AI would do for you anyway. You brush with really broad strokes and don't constrain your ideas. And that's when you can architect the flows, but maybe not be completely declarative on how it's done, other than you're going to use the platform, the atPlatform for all the communication. I think what I've seen, and lots of people on the internet have seen as well, is you can design stuff, but you need to have a platform, otherwise you just get spaghetti. And people like Lovable, the platform's a website. And you can actually, it's sort of fun. You can put one of our blueprints, one of the prompts into Lovable, And it will come up with a beautiful website, but it will also say, you need the app platform to actually get this to work because they don't do live communication. You're sort of ball and chained against a website. And the web semantic has been around since the 90s, I guess, and it has a fundamental flaw. And the fundamental flaw is whoever's running the website can see your data. And so that whole semantic of using a website, and that means every single API. Whoever's running the API, you have to trust them because they will see your data. The app platform's different. We cannot see anybody's data, although we run the infrastructure for you. And the reason for that is you cut your own cryptographic keys and we never have them. So we literally cannot see anybody's data going through the app platform, and yet we provide it. That's a fundamentally different semantic.
Colin, sorry, just to timing on that.
Yeah,
I was having sorry, Jason, to call you out. Jason, CIO, and he was asking me, I was having lunch with him and he said, "Hey, why is that possible?" I was saying, with a lot of technologies, they can see in that middle layer,
yeah.
but with Atsign, you cannot see in the middle. And he said, "Why is that?" And I said, "Well, we need Colin on the call for that."
Yeah.
If you
Yeah,
wouldn't mind, just kind of high level, why is it different?
yeah. Why is it different? Because we believe, and it comes from some of myself and Barbara and Kevin's background when we founded the company was data ownership's difficult if you're an IT shop, right? I spent a lot of my career in IT and a lot of time and blood, sweat, and tears trying to find a data owner. I imagine you have the same problem, Chris. Like, who's the data owner?
Mhm.
The data owner is the person who has the cryptographic keys. And if you have somebody issue the cryptographic keys, guess what? You are the data owner. And that comes with responsibilities, right? So it does come with responsibilities. You actually own the data and you can't make it IT's problem because you own the data and you own the keys. So there is a mental shift there. And cutting your own keys means that you own the keys to the data and you can decide who gets to see which bits of data. And anybody in the middle can't see it. And guess what? We're in the middle running the platform. We literally cannot see anything. So imagine a platform built on Signal or WhatsApp type technology. That's essentially what we built. But the IM's not everything, right? There's all sorts of difficult use cases you have to deal with, like store and forward and RPC and all the rest of it. So, but in terms of a mental model, that's what it is. So that means you need to have a handle, right? So if somebody's going to own data, you need to have a handle to connect to them, and that's what we call an atsign. So the handle, the human readable aspect is the atsign, and the difference is that you have to cut and manage your own keys. It's a little bit about I mean, the analogy you can have in your head, I think, is if you go to the hotel, you have a hotel key. That's great. But guess what? The hotel can still get into your room. If you have your apartment, you have the keys. So you have the responsibility of the keys. And that's exactly the same with that sign.
Mhm.
Now, that doesn't mean to say you have to deploy it like that. We have customers already that said, we're an enterprise or an application and we want to own all the keys. That's fine. You know who the data owner is. And you can issue keys to your staff or your customers or whatever. But you own the keys. You're the data owner. And so it's very, very clear. So there's always decisions to be made, but our platform doesn't prescribe exactly how you use the app platform. There's many ways of different people who can use it. But the underlying problem that we were trying to solve with it was, as the platform provider, we can't see we can't see any of your data. We might be able to see who you're talking to. That's probably about as limited information as we can get. And even that, we can work with you to, if that's a worry for your particular use case, like you're a government or whatever, then guess what? You can run your own infrastructure for the bits that can see that metadata. So the relay points essentially, and you can run your own relay. So a
Colin, can you do me a
long
favor?
answer for a
No, I
very small but
appreciate it.
very, very important question.
Do you mind sharing your screen again? Just the flow that you were just showing with either one, the radio tower or the other flow?
Sure.
Colin, do you have the chat app flow?
I think I do. Yeah, let me show you that. I will get that up.
Yeah, so basically anybody can make their own end-to-end encrypted chat app. What's
And
that?
it's actually in the example right here. So you can go to AI Architect and go to the example blueprint. And it says secure messaging blueprint. And there you go.
There's just something I want to point out for,
Yeah.
this is coming at it from a consulting perspective. And one of the things that we first do when we sit down and we say, hey, there's a process or a technology landscape and it's not working. So the first thing that we do is we sit down and we map it out as almost as you've mapped out here.
Yep.
So, and then we say, okay, there's a gap between the person and the process. And then we say, this is what needs to be done. And then we write specs for it.
Yep.
But the really cool thing is that you're doing all that right now. You're saying this is the application, these are
Yep.
the person or the entity or the thing involved, and then it just develops code, the application on the fly. It's almost reverse engineering that complete process. You're
Yep.
basically putting us out of a job, Colin. You
No,
just
what I found is the human aspect of it here is way, way, way the most important thing. And this is a skill that few people have. On our team, that's Tinashe. Tinashe's just unconsciously competent at doing this stuff. Um, and that's what I think you need. You need consultancy, and it's very difficult if you are the person with the problem. You're too close to the problem to be able to zoom out. So consultancy, building these blueprints, crazy, crazy, crazy important. Um, because the detail in here just gets sent to the LLM to build the code for you. So what you are doing is, accelerating the coding process, but you're also accelerating the consultancy process because we spoke to somebody recently who said like, this is just going to save me so many PowerPoints.
yeah.
Like,
Hmm.
because this is the PowerPoint.
Yeah.
So instead of moving around and playing jockey with PowerPoint, you can actually use a real blueprint, which immediately
Well,
turns
and
into code, right?
yeah, the PowerPoint and the team. So, you start with a very functional specification, a business
Yep,
requirements. Then you get into how you need to configure, and then how you need to code, and then the developers to code it and unit test it and all. And this is kind of nope. You just talk very natural language,
yep.
that how they interact and what you want it to do, and then I'll say your initial prototype is done, and like you said, there might be tweaks after the fact, which
Always
you
going
can
to be
do.
tweaks. Yeah, yeah,
Yeah.
yeah. So one of the things we added recently, we have a couple of really good designers on the team, and they said like, well, yeah, how do I put in the design spec? I'm like, good question. Because there's not a sort of where do you put that? Well, you have a sticky note. And you put in the design spec in there, and this will apply the design spec, like logos and colors and all that good stuff you can put in, or maybe the list of widgetry that you've already got written. So yeah, that this is one of the biggest boundaries I think to getting code done. Translating the business idea into a blueprint that everyone can agree. The next boundary used to be like, write a code, then go around in a circle for a long time. That's just,
Yeah.
that's a, killed stone dead. But the last barrier is how am I going to get this in production? Because, how was the code delivered? How secure it is? Or, how can you show the process flows? How am I going to monitor it? All those really good questions. And that's, building on the app platform really, really helps with that stuff. So, yeah.
Awesome. Well, I do want to, we have about 15 minutes left, and I'm sure there are questions out there, so I just want to open it up and see if anybody has any questions or comments.
A question. Are you able to hear me?
Just fine, Jack. Go ahead.
Cool. One thing that I really liked about this platform is the visualization of the flow. And one question that I had is is this platform like modular? Like, is it able to be made modular, like modularizable? Because one thing that I thought of was like, what if I made the base part of the app and then I wanted to have, I don't know, some kind of extension? Would that be a separate flow, or is that like I'm going to add on to the original flow?
Yeah, that's a great question. So you can let me show you. Um, it's easier to show you. So the way to do that is at the moment you have a secure messaging. This is secure messaging, and guess what? You can add a new page, and it's on the same plan. So this is obviously page 2, and let's just rename that.
Yeah, you're right, Colin. This is the PowerPoint.
Yeah, exactly. So rename that API to Claude, and then you've got secure messaging here, and your Pi, and it should be API to Claude. So that's the way I would do it. And you can, when you do into the plan mode, cut and paste it and say does focus on, does focus on the API to Claude. The other stuff's done. So that's how I do it. Or you can have a separate blueprint, and you can refer to the other blueprint. Um, both of those approaches work really well with, I would say, the latest models. So you really want to be on the latest Gemini or 4.5 version and above of the Claude models. Yeah, I mean, until probably 3 months ago, I guess it would have struggled with this. Now it's just not a problem anymore. Does that help?
Yeah, I like how flexible it is. That's definitely a huge strength, and definitely also like you're right. As the models get better, they're just only going to get better at executing, I guess, the instructions that we set out for them.
Yeah,
Another thing that
yeah, go ahead.
yeah,
Sorry, Jack.
yeah, no. Another thing that I really like about this is, as when I'm doing business stuff, it's really hard when I have something in my head. You get it out quick. Like you see the things that you don't like in your radio example, the settings bar, or like,
Yeah.
oh, we want settings. Just getting it out quickly is a huge strength to just be like, okay, now I see it, and no, people can rally around the flag and start throwing stuff in. But yeah, really cool stuff. I love this.
Thanks, Jack. Any other questions out there?
How do we do, Keith? You had to the questions originally. Did we answer everything you had? Did it make sense all of a sudden?
I would say total, but enough
There's a lot to take in.
to keep me happy for the present. And it's just a curiosity that I couldn't quite visualize. If you don't have an IP address, how do you actually authenticate yourself to get on? And when you said it was a separate app that
Yeah,
started that process,
yeah,
that made perfect sense. Yeah.
yep. Yeah, so we still use IP, so we're big fans of IP. So we fundamentally only use TCP IP.
Hmm.
Because then it's a lot easier to, well, in fact, it's possible to go through firewalls and NATs and all the rest of it without sort of doing any jiggery pokery. Um, and so, but you're always making an outbound connection to infrastructure that provides the connectivity to everything. So everything's outbound meeting at a place, but the meeting place can't see your data because it doesn't have your keys. So it's just
Hmm.
acting as a router essentially, just like any other bit of infrastructure. But it's a software router, if you like, rather than a Cisco or a Juniper router.
Yeah.
Hey, Colin, can you speak to the scalability of the solution, in terms of, I mean, simultaneous logins,
Yeah.
can you
Yeah.
get to
So
an ERP level or yeah, go
yeah.
ahead.
So this is again a fundamental difference in the way we've done things. So generally, when you're building stuff, you end up with a lot of servers or a few servers, then you have to go buy a load balancer, and then you have to buy a load balancer for the load balancers to be able to go to different data centers, and you end up with a whole bunch of infrastructure that actually I like managing because my history is network infrastructure. I love that stuff. but it's super expensive and to manage. So we didn't go down that route. We went around a very radically different route in that every atsign has its own bit of infrastructure, and every atsign essentially has its own Docker container. And so when you're authenticating to your own Docker container and not some big server. It's an individual tiny Docker container. It's about, I think the latest version is about 10 megabytes and it uses about 50 megabytes of memory. It has its own little database, in-memory database, so that's why it's snappy. And that means that scaling's easy. Just add more containers. And what we use on the back end is sort of interesting. So we have a directory service. So basically, you go to that directory service at Colin, and it will answer back the DNS record and the port number of that individual at server for at Colin. And then you can talk to that, and I'm off to races. And then they can, each ad server can speak to its own. In terms of infrastructure under the skin, everything's software defined. So we use Kubernetes for the directory service so that instantly scales up and down. So there's no scalability problems there. It's just off the shelf Kubernetes. For the Docker containers at scale, and we have many, many, many thousands of these things running. We use something called Docker Swarm, which I keep getting told is very old school. And yet, interesting enough, in the last probably year or so, I've seen Kubernetes people moving back to Swarm because it's just so simple and super scalable. And because every container is individual, Swarm is actually good. So we use Kubernetes and Swarm, both scale up to many, many millions of atsigns. And we have something up our sleeve which will get us easily to billions. So this was built for 50 billion. That was where the architecture was, and we know exactly how to do 50 billion. So I'm not worried about scalability because we scale out horizontally. I mean, my dream is to have an atsign to on every single thing on the planet. So an atsign on my light bulb would be really cool. So I can just say, somebody's visiting my house today, I can, what's your atsign? I'll just program on my house to accept your atsign and I'm done, right? You can switch on the lights, you can switch on the TV, you can move your preferences over from the TV. Energetic flows inside an enterprise, as somebody joins, you issue them an atsign and that's it, you're done. That's a brave new world.
So you're talking about interplanetary, then I'm assuming the scaling question is
So
good
I've actually
for now.
been speaking to the interplanetary guys, and they need to sort out IP first. But yeah, we're just kind of just trying to conquer Earth for the moment. Yeah.
Okay. So we did have a question in the chat from NT. He said that these graphical interfaces come and go. They usually get clunky for large models. Will there be hierarchical versions?
So at the moment we use pages. So we'd have a page for every sort of individual project. But yeah, I mean, as you use it, we take feedback really, really seriously. Most of what you see is through feedback, as the initial people using it were using it. So yeah, please give us feedback, and we'll answer it. It's it's exciting stuff. Everything changes on. I don't know on a daily basis, maybe hourly basis at this point, Barbara. That's probably where we've been.
Okay, thanks, Colin. Last question, if there are any, and then I'm gonna wrap up. Any last questions or comments? Okay. All right, here we go. Okay, so call to action. So if you're interested, if you want to find out more about the platform, about maybe doing a pilot example, please reach out to myself, reach out to Barbara, Colin. We can schedule a demo session and do this on an actual case study that is near and dear to your heart. Coming soon, the @Architect Starter Pack. Barbara, you want to talk a little bit about that?
Yeah, that just gives you 2 atsigns and access to the AI Architect product, and you can play with it yourself. So that's actually should be available today on our website,
Very cool.
atsign.com.
Thanks, Barbara. And the next Venture West AI webinar, you can look on LinkedIn, but it will be March 11th, and it will be around the top 10 lessons deploying AI. So all of you that are thinking about it that have not yet deployed, we have our resident speaker, Emily Lee, who led the Center of Excellence at VMware, and she and myself will be presenting that on the 11th. So sign up, and that will be the next session. And I think that is it for today. Any last comments or questions? All right. Well, I definitely want to thank all of you for joining, and I want to thank Atsign, Barbara, and Colin. Thank you so much. Very informative session and really exciting stuff. Very grateful to have you guys on.
Thank you
Yes,
so much
Chris.
for having us, Chris.
All right. Thanks, guys.
Thanks, everybody. Have a good one.
All
Thank
right.
you,
Enjoy the
everybody,
rest of
for
your week.
joining. Thank you.